Okay, so this question is a continuity question, and it deals with the three conditions of continuity that we talked about in our last class together. And just going to throw this up here. These are the three conditions that we've talked about, right? Your function has to be defined at that point, the limit has to exist at that point, and the limit has to also equal the function output at that point. As long as all three of those are met, then the function is continuous at that certain point. So let's look at each one of these points, A, B, C, and D, and let's just run through these conditions. The question here says state the failed condition. So we have to figure out which one of these conditions fails if it's not continuous. So let's start by looking at point A. Okay, at point A we have a vertical asymptote. Okay, so let's look at our conditions here. Is the function defined? Okay, is a function defined at a vertical asymptote? No. So that's a condition that fails. So I'm going to say f of c, or you could have put f of a here, is defined. That's a condition that fails at point A. Let's look at our next one, our next condition. The limit must exist at that point. Well, again, at a vertical asymptote, the limit doesn't exist, so that is yet another condition that fails at point A. And again, you could also write limit as x approaches A, f of x exists. That is also a condition that fails. Okay? This third one, since the limit doesn't exist, we're not going to worry about that matching anyway, so it's really just these first two. At the vertical asymptote, it's actually not defined, and at the vertical asymptote, the limit doesn't exist, so it fails both of those conditions. Okay? Let's try point B. Okay, again, we're looking at our three conditions down here. Must meet all three of these. So at point B, let's take a look at this. Is the function defined? Okay, so that's the first thing that we have to look at. Is the function defined? Well, at point B, it actually is defined, right? We have a closed circle here, and so that's your output at that point. So it meets this condition, okay? Second part, does the limit exist at point B? Well, let's go back to point B. Coming from the left side, coming from the right side, we're both approaching the same point. Even though it's an open circle, it still exists. We're both approaching that same point. So the limit exists. Okay, so far we've met this condition, we've met this condition. Let's go down to our third one. Does the limit, as x approaches that value, is that the same as the function output at that value? Okay, so let's see. The limit as x approaches b, okay, is going to exist right here, okay, at whatever y value this is. However, the function is defined at this closed circle, whatever this y value is. Are those the same? They're not, okay? So down here, this is the condition that's going to fail us for this part B here. So I'm going to say the condition that fails, limit as x approaches c, f of x is not the same as the function value at that point. So I'm just going to write a fails next to it. Okay, let's try C. We have two more. Okay, C looks like we have a jump at this spot. Okay, so let's take a look at this. Is the function defined? Yep, it's defined at C, right? You just look for the closed circle. It's defined at C. Be right here. Okay. Let's ask the next question to ourselves. Does the limit exist at that point? Well, again, we have a jump here, so obviously it's not. If we're coming from the left, we're up here. Coming from the right, we're down here. We're not meeting at the same spot. Okay, so it looks like the condition that's going to fail us is right here. The limit actually does not exist. Okay, so it can't be continuous. So I'm going to say limit as x approaches c, f of x exists, that's the condition that's going to fail us. Okay? All right, and finally, at point D, okay, point D is right here. Looks like we have an open circle. And let's, again, run through our three conditions. Is the function defined at that point? Well, it's an open circle, okay? It is actually not defined when you have a hole, when you have an open circle, okay? It's not the same thing as a limit. It's not actually not defined, okay? So that's the condition that's going to fail us there. I'm going to write FC is defined, and that's a failure. Okay, and again, all we did here is just taking a step back. It says state the failed condition of continuity. We went through and we listed the conditions that were failed at each spot. Okay.